This video is over real-world systems of equations. Before we start, I would like you to go to your GoFormative and check to see if you got the two equations right on number 2. This problem that we're looking at right here is the same question as your GoFormative number 2, and all I asked you to do was to find the two equations that would set up the system, not necessarily solve them, just the two equations to set up. So before we even start, go look at that and see how you did. To review that question, it says there are 120 people attending a wedding reception, and there are 16 tables. Some are round tables and some are square. The round tables seat 8 people and the square tables seat 6 people. And our question is really, how many of each type of table must there be at the reception? The question usually gives away exactly what we're looking for. So if you look at your GoFormative, that's where I got the two variables from. We know that x is equal to round tables, and we decided that y is equal to square tables. And those are our two variables, and we wanted to find them so we can write a sentence later exactly what we found as a solution. The equation that most people got was this one, and it had to do with the 8 people and the 6 people. A lot of people realized that, okay, 8 people can sit at the round table, so they put 8x. And 6 people can sit at the square tables. And altogether, if we have a certain number of round tables that fit 8 and square tables that fit 6, 120 people in total are going to be at that reception. A lot of people got that equation, and that's usually expected. It's the second equation where people have a little trouble, and it has to do with this 16 table part. The 16 table part helps us with our next equation because we know that there's some combination of, what happened there? There's some combination of round tables and square tables that makes 16. That equation right there is usually the more difficult one to figure out. But now that we know that's where that equation is coming from, the fact that round and square make 16, you'll notice a pattern in all your systems of equations with real-world scenarios applied to it, that you'll have an equation, something like that. So I'm going to choose to solve this by elimination. I think it's going to be easiest. And the first thing I'm going to have to do is multiply the bottom equation by, I'm going to choose -6 just to keep our numbers a little bit clearer here. So when we multiply the bottom by -6, we will end up -6. There we go. The top equation stays the same. That's still 8x plus 6y equals 120. And our new bottom equation now is -6x minus 6y is equal to -96. In this case, remember this is the 20. All right. We notice really quickly that our 6y and our -6y are going to cancel each other, so that's good. That was the point of elimination. When I add the two together, 8x plus a -6x gives me 2x. These cancel one another. And here I'm left with positive 24. So I must know that x is equal to 12. So I'm going to write the coordinate point in our answer box. Even though we're talking about a real-world situation, I'll still include the answer here, and then we'll describe what it means in a few minutes. Now, knowing x equals 12, I want to figure out what y is, and I'm going to use the second equation to help me figure out what y is because it's pretty simple. If x plus y equals 16 and x equals 12, using substitution, if I subtract 12 from both sides, I get y equals 4. So these two equations are going to cross at 12, 4, but what that actually means in terms of our problem relates back to this original equation. How many of each type of table must there be at the reception? So since x represents round tables, we could say at the reception, and again, this is the most important part. It tells me not only do I know how to do the math, but I know what's going on. At the reception, there can be 12 round tables and 4 square tables. So that is how we solve systems of equations in the real world. Again, that second equation is usually most difficult, but let's try one more example and hopefully you'll see some similarities in this case. Okay. Now we're going to go to our second question. Make sure you are able to look at that as well. I'm trying to move my screen. There we go. Okay. If you have a highlighter, if you want to get that out, that might be helpful right now for you as well. Let's go ahead and read through this one. It says that Castell and Gabriella are selling pies for a school fundraiser, and customers can buy apple pies and lemon pies. So there's our variables right there. Castell sold 6 apple pies and 4 lemon pies for a total of $80. Gabriella sold 6 apple pies and 5 lemon meringue pies for $94. What is the cost of 1 apple pie and 1 lemon meringue pie? So notice again, our variables are coming right from that question. An apple pie, a lemon meringue pie. So let's say that X equals apple pie. And apple pie cost, let's be real specific, apple pie cost. And then Y equals, again, where are we? There we go. Y equals, I know it says lemon meringue, I'm just putting lemon pie cost. Okay, so let's set up our 2 equations in this case. Here we have 6 apple pies, so 6x plus 4 lemon meringue pies, 4y, equals 80. And then Gabriella, her equation would be 6 apple pies and 5 lemon meringue pies was $94. Perfect. All right. So again, these 2 equations represent the knowledge that we had. To relate it back to the first one, if there was a sentence like, in total, they sold 50 pies, then we know it'd be X plus Y equals 50. But using elimination, this one's going to be pretty easy. I'm just going to multiply the bottom equation by -1, changing all of my signs to negatives. So my top equation stays 6x plus 4y equals 80. My bottom equation becomes -6x minus 5y equals -94. And for my people who say, couldn't I have just subtracted the 2 equations? Yes, you could have. You would have gotten the same exact answer there. Move this line down a little more. There we go. All right, so from here, I've got 6x minus 6x, and I know those are going to cancel with each other. 4 plus -5y gives us -1y, and -80 minus 94 gives us -14. When we divide by -1, we get y equals 14. So again, we'll think about what that means here in just a second, but I'm just going to write that as a solution, as a coordinate point in my answer box. Now, knowing y is equal to 14, I can figure out what x is. So I'm just going to use the top equation. Remember, it does not matter which one you use. And we'll use the substitution property of equality to substitute that 14 in for y. All right. So the first thing we need to do is that 14 times 4, and that gives us 44. That would be 14 times 11. That gives us 56. So we have 6x plus 56 equals 80. When we subtract 56 on both sides, we're going to get 24. So we'll have 6x equals 24. And in this case, x equals 4. All right. So our 2 pie costs we have here in this this coordinate right here. Since x represents apple pies, we could say each apple pie costs $4, and each lemon pie costs $14. Now, as you continue on, look at the difference between the 2 questions. I do want to remind you that when you're looking at questions like the one above, where they give you a combination, like there was a certain amount of square tables and round tables to make 16 tables, just remember that equation can be very simple. Don't let the simplest part of the problem hold you up. All right, good luck.